Let's talk about a concept used a lot with a standard normal distribution. It's called the z-score. Z-score. And so what a z-score is useful is when you have a set of data, each data value can be assigned its own z-score. And a z-score is applied the same way to a data value no matter what the data value is within any type of data. So a z-score of 1 means the same thing in one data set as it does in another data set. So what is a z-score? A z-score for, and you know what, let's say the z-score. There's only one z-score for a data value. The z-score for a data value tells you how far the data value is from the mean in sort of a standard way. So the way to measure that standard distance is to measure it in terms of standard deviations. So the z-score for a data value is the number of standard deviations, from the mean. And so any data set could be broken down to a mean, and a standard deviation could be calculated. And then if you want to count how far a data value is from the mean, you do it in terms of how many standard deviations from the mean. Now, the idea here is that numbers that are below the mean have a negative z-score, and numbers above the mean have a positive z-score. So if you were to look at this on a scale, then let's say the mean data value, let's say, is in the middle here. Well, the z-score for the mean would be 0. And we write that as z equals 0. And that's because it's 0 distance from itself. And then as you deviate to the right, you have positive z-scores. And as you deviate to the left, you have negative z-scores. So any data value that is 1 standard deviation above the mean, we say that it has a z-score of 1. So here we are 1 standard deviation above the mean. And then at z equals 2, you would be 2 standard deviations above the mean, etc. And over here, 1 standard deviation below would have a z-score of -1, and so on. So negative z-scores indicate the data value is below the mean. Positive z-scores indicate above. And I don't want to give you the false impression that you can only have whole number z-scores. You can have a z-score of maybe 1.2 as well. You can be a decimal distance of standard deviations from the mean. Okay? So let's talk about how to calculate a z-score for a data value. Let's do an example here. And rather than writing a long paragraph and giving this context, I want to focus on the math concept. Okay? So let's say that we have a data set. So let's say data has a mean of 78 and a standard deviation of 6. Okay? So that's the scenario we're working in. And so question A might be something like, what data value has a z-score equal to -2? Okay? So this is the z-score for some data value in this set. And so the idea is, what does it mean if we say z equals -2? Well, that means we are 2 standard deviations below the mean. And we know that 1 standard deviation is 6 units in this case. So what we would do is we would take our mean and we would subtract 2 times our standard deviation. Subtract 6 twice. And so 78 minus 12 is 66. So the data value 66 has a z-score of -2. In fact, lots of times the way we would write that is we could say the z-score with a subscript of 66, meaning the z-score for this data value equals -2. But the answer to this question is just 66 is the data value. Okay? Now let's go the other way. Let's go the other way. And find out what is the z-score for the data value, let's say for 84. Okay? So what is the z-score for this? Well, if you think about the data, we have a mean of 78. That's our mean, is 78. And then 84 is over here. And we want to know how many standard deviations we have here. How many units of 6 do we have? Now, I understand this one's very easy, right? You could look at this and probably figure it out. But I want to focus for this easy example on how to think about it when it gets more complex. So how do we figure out how many 6-unit measurements fit here? Well, the first thing we want to do is, well, z equals, in fact, we're finding the z-score for 84, so why don't put a subscript of 84 there? The z-score for 84 equals, the first thing we're going to do is, well, we need to figure out how far apart these are. And 84 is bigger, so we want to make sure we get a positive answer for our z-score. So we'll do 84 minus 78, and that's going to give us a positive number. If we had a number smaller than 78, we would take that smaller number minus 78. We always want to subtract our mean to find this distance. Now, this is going to give us a number, right? But we need to figure out how many units of 6 will fit in this distance. So we have to divide this by the standard deviation to ask ourselves how many standard deviations fit in this distance. And so you can see that 84 minus 78 is 6, divided by 6 is 1. So the z-score for 84 is 1. And that's because, right, if we label these with z-scores, the z-score for the mean is 0 because it's 0 standard deviations from itself. 84 is 6 units above, which is exactly 1 standard deviation. So the z-score here is positive 1. Okay? So that's pretty easy to see. Now the next couple examples, I want to focus more on how to do this if we don't have an even number of standard deviations. So question C, what data value has a z-score of -1.4? Okay? So this is more realistic, dealing with decimal z-scores, but the idea is exactly the same. So if you got the basic whole number z-score idea, use the same concept here. So what we're going to do is, if we have a z-score of -1.4, that means we're 1.4 standard deviations below the mean. Well, 1.4 standard deviations means we're 1.4 sixes. So what we have to do is we have to multiply 1.4 times 6, and that's going to tell us how far we are from our mean. Okay, so this tells us how far we are from our mean. But because this is a negative z-score, we know we're below the mean. So what we have to do is we have to subtract this from the mean to see how far below the mean we are. So this is going to equal 78 minus, let's see, 1.4 times 6 I think is 8.4. And if we subtract that, we get 69.6. So the data value 69.6 is 1.4 standard deviations below the mean of 78. Okay? Let's do one more example where now we calculate a z-score. So part D. So the way I'll write it this time is determine z with a subscript of, let's say, 75. Determine z sub 75. And what that means is, what is the z-score for the data value 75? So again, if we look at a diagram, the mean of 78 is here. The data value we're interested in is here. Of course, this mean has a z-score of 0. So this 75 definitely has a negative z-score. And you have to remember the definition of z-score. How many standard deviations are we from the mean? Well, just like before, we have to figure out, all right, let's take the distance between these. So we'll do 75 minus 78, which will give us a negative number, which is what we want because this number is below the mean. So 75 minus 78 is going to tell us the distance between these. But then we have to ask ourselves how many sixes, how many units of 6 fit in here. So we have to divide this by 6. And that's going to be how we calculate the z-score for 75. Well, 75 minus 78 is negative 3. Negative 3 divided by 6 is negative 0.5. So the z-score for 75 is negative 1/2, or negative 0.5. That's how many standard deviations we are from 78. We're half a standard deviation below. And that makes sense, right? This distance is 3, which is half of 6. So we're 1/2 of a standard deviation below the mean in this case. So you may be catching on to how a z-score is calculated. And I always hesitate by leading with this formula because students tend to want to memorize things. So here I've hopefully helped you develop an intuition for how to calculate a z-score based on this definition. And that's maybe the most important part. Know the definition of a z-score. From there you can do anything you want with it. However, I don't feel like this video would be complete without mentioning the generic formula for calculating a z-score. So to calculate a z-score, you already have the idea. You start with your data value, whatever it happens to be, and then you find out how far it is from the mean, so you subtract your mean. So you've got a distance between them, but then you have to ask yourself, okay, how many standard deviations will fit in that distance? So now you have to divide this difference by your standard deviation value. And so what you see is, if your data value is smaller than your mean, this should be a negative number. If your data value is bigger than your mean, this should be a positive number. Okay? So that's how you calculate a z-score. But you already knew that from the examples we looked at.